All right, everyone, before we jump into the deep end, just a quick heads up. The best way to make sure all this stuff really sticks is to practice. So, when we're done here, head over to mcqpm.com or grab the app and really test yourself, okay? Let's go. Welcome. Today, we are tackling a huge topic for your SPM Chemistry paper, hydrocarbons. My goal here is simple, to help you crack the carbon code so you can walk into that exam feeling totally confident. So, let's kick things off with a very typical exam question. Look at this. You've got two hydrocarbons, M and N. One is an alkene, the other's an alkane. In a lab, how in the world do you tell them apart? Take a second and think about it.
Now, if you're kind of staring at that question and your mind's gone completely blank, don't worry. You are definitely not alone. It's a super common sticking point. But trust me, by the end of this, you'll be answering questions like this in your sleep. So let's break it down together.
You see, the entire secret to that question, and honestly so many others, comes down to understanding one single fundamental idea: the difference between saturated and unsaturated hydrocarbons.
Okay, so first up, we have saturated hydrocarbons. The big key word here is single. Saturated means all the carbon atoms are connected by only single covalent bonds. They're full, they can't hold anymore, and the family you need to know, that's the alkanes.
And on the flip side, we have the unsaturated hydrocarbons. Now these are a bit more interesting, chemically speaking. They have at least one double or even a triple bond between their carbon atoms. For SPM, you're going to be focused on the ones with double bonds, the alkenes.
So this right here, this is the stuff you absolutely need to commit to memory. For saturated alkenes, it's all about single bonds and that general formula, CnH2n plus 2. For unsaturated alkenes, you're looking for at least one double bond and the formula CnH2n. These formulas are your cheat codes for exams, seriously.
I get it. Formulas and bonds can feel a little abstract. So to make this idea really stick, let's use a simple analogy. Just think about a bus.
A saturated alkane is like a bus that's completely packed. Every single seat is taken. It's saturated with people. You can't add any more passengers. But an unsaturated alkene, that's like a bus where you have those double seats. The double bond is like having a spot where you can break it open to fit more people. You can add more passengers, or in our case, more atoms. And that ability to add things is the whole key to their chemistry.
And that brings us right back to our original question. Because alkenes can add atoms, they do something alkanes can't. If you pour in some brown bromine water or that bright purple acidified potassium manganate, an alkene will break its double bond, grab those new atoms, and the color just vanishes. It gets decolorized. An alkane can't do that, so the color stays exactly the same. And there you have it. That's the test.
Okay, so we've got the theory down, but where do we even find these hydrocarbons? Well, let's zoom out and look at one of the biggest industrial processes on Earth, where all this chemistry happens on a massive scale.
Well, the main source for pretty much all the hydrocarbons we use is petroleum. You know, that thick black stuff we call crude oil. It's basically this complex cocktail of thousands of different hydrocarbons all mixed together. But you can't just pump crude oil straight into your car, right? We have to separate that messy mixture. And the magic happens inside one of these giant towers, using a process called fractional distillation. So inside this column, the oil gets heated up, and it separates based on boiling points. It's actually a really neat sorting process. The smallest, lightest molecules, like petroleum gas for cooking, have low boiling points, so they rise all the way to the top. The medium-sized ones, like petrol and kerosene, condense out in the middle. And then the really big, heavy, clunky molecules, like bitumen for making roads, they stay right at the bottom. And this is the trend you have to remember for exams. Small molecules, low boiling point. They're less viscous, meaning they're runny, and they catch fire really easily. Think petrol. Big molecules are the total opposite. High boiling point, super thick and viscous, and they don't burn so well. Think of that sticky bitumen used for roads.
All right, we've talked theory, we've talked real-world application. Now let's bring it all home and see how we can use this knowledge to absolutely crush some typical SPM questions. It's all about spotting the patterns.
Let's look at this first one. Ethene can be differentiated from ethane because ethene can. Come on, this should be ringing some bells now, right?
Okay, here's the thought process. First, I identify the players. Ethene ends in -ene, so it's an alkene. Ethane ends in -ane, so it's an alkane. The key word is differentiate.
That's my cue. I immediately recall the main concept. Unsaturated alkenes are the ones that do addition reactions. So boom, the answer has to be that ethene decolorizes bromine water. Simple as that once you see the pattern.
Let's try another one, a slightly different style. This time, they give you the chemical formulas, C4H8 versus C4H10. What's a key difference between them?
First, let's use our general formulas. C4H8, well, that fits CnH2n, so that's butene, our alkene. C4H10 fits CnH2n plus 2, so that's butane, the alkane. Now, here's a common trap students fall into. They only think about the bromine water test, but there are other differences. Alkenes have a higher percentage of carbon, so when you burn them, there isn't always enough oxygen to burn all that carbon completely. The leftover carbon, that's soot, so alkenes burn with a much sootier flame. That means compound A produces more soot.
See, once you know what to look for, these questions start to look a lot less scary. But knowing isn't enough. The only way to get really good and really fast is through practice. So it's time to level up. Go on, pull out your phone right now and scan this code. It'll take you straight to MCQSPM.com. There are thousands of questions on there just like the ones we've covered. Or you can just search for the app on the Google Play Store. Seriously, repetition is how you build that exam day confidence.
And I'll leave you with this final thought, just to connect all this chemistry back to your own life. We've seen how we get everything from cooking gas to the asphalt on the roads from crude oil. So, which one of those hydrocarbon products do you think is the most essential to your daily life? Give it some thought. Thanks for watching, and I'll catch you in the next one.